This video is intended to be watched prior to our flipped classroom day where we will be discussing section 4.7 on combinations. The definition is as follows. A subset of a set S is a combination of elements of S. You can think of a combination as being R things chosen from a set of S, which itself has n elements. Combinations are similar to permutations, which were discussed in the previous video. However, the order does not matter. So for example, if you wanted to select 3 different colored flowers to be part of a bouquet, and you were going to select blue, red, and white, this would be the same selection as white, red, blue. So in a combination, the order in which you select the items does not matter. It does not get counted as a distinct option. They would be considered the same option in a combination. NCR is the same, it's in the same menu as NPR on your calculator. And there are 2 ways in which you can write your combination notation. You can write NCR, or you can write a parenthesis with an N on the top, an R on the bottom, and an extra parenthesis. We saw the second notation earlier in the year when we talked about binomials. We are going to take a look at a few problems from out of your textbook. So if you do not have your textbook, I would encourage you to pause the video, pull out your textbook, and turn to page 310. We're going to start with number 1. So question number 1 on page 310 says, how many different committees of 4 people are possible in a class of 200 students? So in this situation, if you're selecting a committee, there's no hierarchy within that committee. So all 4 committee members, no matter the order that they are chosen in, if you had student X and then student Y as part of the committee, then student Y and student X would be the same committee. So the order does not matter in which you select the items. So we're going to use a combination here. We have 200 students, and we're choosing 4 of them. So you could write 200 C4, or you could write 200 choose 4 this way. Using the definition that we have above, this would be written as 200 factorial divided by 4 factorial times 200 minus 4 as a quantity factorial. Now you can either type that into your calculator, or what I think is a little bit easier is to use the NCR button in your calculator. So the way that you would do that is you would first start by typing in the number 200, then click Math, which is right underneath the alpha button. At the top, you'll see a menu that says PRB for probability. Select that. And number 3 on your list should be NCR. Then you will type in this case, number 4. And when you do that, you get 6, 4, 6, 8, 4, 9, 5, 0. Lots of different committees. Now let's take a look at number 3. So in question number 3, it says, explain why 200C4 is the same as 200C196. So they're saying, why is 200 choose 4 the same as 200 choose 196? So first of all, I would encourage you to type both of those numbers into your calculator and verify that they really are the same number. They are. But the reason that they are the same is, for example, when we talk about our committees, like in question 1, there are 6, 4, 6, 8, 4, 9, 5, 0 different ways for you to select 4 people to be in a committee out of 200. But when you select the 4 people to be in that committee, you are also selecting 196 people not to be in the committee. So in other words, you could select 196 people to be non-committee members the same number of ways as you could select 4 people to be committee members. The next question that we're going to look at is question number 20, which is on page 311. Question 20 says, find a formula for the sum of the entries in any row of Pascal's triangle. So the first thing I'm going to do is make Pascal's triangle, just in case you forgot. I'll just make a couple rows here for us to explore. I'll stop here. If you're going to add up each of the entries in each of the rows of Pascal's triangle, that first row that we sometimes call row 0 would have a sum of 1. The next row would have a sum of 2. 1 plus 1 is 2. The next row, 1 plus 2 plus 1 is 4. Then you're taking 1 plus 3 plus 3 plus 1. That's 8. 1 plus 4 plus 6 plus 4 plus 1. That's going to give us 16. And then 1 plus 5 plus 10 plus 10 plus 5 plus 1 is 32. And this pattern is just going to keep continuing. So hopefully some of you are able to see the pattern here. You'll notice from each line to the next, you're doubling. So we could write this as exponential with base 2. So in other words, this is 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, and then that first 0 row of Pascal's triangle we could write as 2 to the 0 power. So if you're looking at the nth row of Pascal's triangle, and you add up all the entries in that row, you would get 2 to the n power.